We're going to be looking at characteristics of quadratic functions. First thing is axis of symmetry. If I draw a function, let's just say I have this function right here. And if I look at the halfway point, let's just suppose it's x equals 1. That's going to be my axis of symmetry. We call it the AOS. So otherwise known as the AOS, the axis of symmetry is going to divide a parabola in half. The formula for axis of symmetry is going to be x equals negative b over 2a. And suppose we had this formula. We had f of x equals 3x squared minus 6x plus 5. And our coefficients are going to be the a and the b. So a equals 3, b equals negative 6. I'm going to try and find the x value. X equals negative 6 over 2 times 3. So x equals 1. And then we're going to say that my axis of symmetry is going to be x plus 1. So that's how you would solve for x plus 1, or I'm sorry, axis of symmetry where x equals 1 for an equation in standard form. So this is standard form. Okay, next we're going to talk about the vertex. So not only do you use the axis of symmetry as the x value of the vertex, we can also substitute it to find the vertex. So the vertex is going to be a minimum or a maximum of a parabola. Not only is it the min or the max, it's also a turning point of the function. So what I mean is that your function is going to change direction once it hits the vertex. Okay, so let's talk about this. And let's use this f of x function. So the vertex, as you know it, can be h comma k for vertex form, or your vertex can be negative b over 2a, and then substitute that into the function negative b over 2a for standard form. So if we use the original function, f of x equals 3x squared minus 6x plus 5, and I substitute where x equals 1 into the function, I'm going to get 3 times 1 squared minus 6 times 1 plus 5, and my f of 1 is going to equal 2. So now I can say that my vertex is going to be 1 over 2. And I'm getting the x from the axis of symmetry. So if I again graph that, it's graphed right here, this point would be 2. So now I can say I have a 1 comma 2. And because the vertex is the lowest point, it's also a minimum. So let's talk about minimums and maximums. Again, a minimum is the lowest point of a parabola, or you can say it's the vertex. A maximum is going to be the highest point of a parabola, and it's also the vertex. Okay, and then one more thing I want to make sure is that we realize that minimums or maximums are also turning points. Okay, And now you have your x and y intercepts. So x and y intercepts are pretty specific. So in this function that we've been using, we are going to only have a y-intercept. So let's talk about how you solve for an x and a y-intercept. For an x-intercept, what you're going to do is you're going to set the function equal to 0, and then you would factor. So basically, a y-intercept is where the y equals 0. Okay, now you have the x-intercept. This is where the function crosses or touches the x-axis. And to find this, you would substitute y equals 0 and solve for x. Okay, the y-intercept is going to be where the function, I forgot the end there, crosses or touches the y-axis. And then here to solve, you're going to substitute x equals 0 and solve for y. Okay, example A. Look at the graph, state the axis of symmetry, vertex, maximum, minimum, and x and y intercepts. Okay, all you need to do is label the graph. So first thing you need to do is look for the halfway point. So that's right here. And then you also want to circle the intercepts wherever they cross the x-axis. So this one is very specific. Okay, so axis of symmetry. The halfway point is going to be, this is going to be x equals -2. Okay, so axis of symmetry, x equals -2. State the vertex. That's going to be this point right here. So that's -2, 2. So that's -2, 2. Is it a maximum or minimum? This is the highest point, so it's going to be a maximum. The x-intercept is what I first circled. So the one on the left is going to be -5, 0. The one on the right is going to be 0, 0. And then the y-intercept is also the same as the x-intercept, so it's going to be 0, 0. So you have an x and a y-intercept that are the same. Okay, here's the second graph. Example B. Let's label that. And circle our x-intercepts. And let's circle the y-intercept. It's also the vertex. So the axis of symmetry, this is again an x value. This is going to be where x equals 0. State the vertex. I'm going to get 0. Let's see. It goes x. It doesn't move left or right. And then it goes down 10. So it's going to be 0, -10. The maximum or minimum, it's a low point. So that's going to be a minimum. The x-intercepts, let's label these. So I'm going to have -3, 0. And the one on the right is going to be 3, 0. And then the y-intercept, this right here is the y-intercept. So that's going to be 0, -10. Okay, C is going to be a parabola, y equals x squared plus 17x over 2. It's asking you to find the axis of symmetry, the vertex, and then state if it's a minimum or maximum. Okay, so this is going to be a positive 1x squared plus 0x plus 17 over 2. I'm writing it in standard form. So that's kind of what you want to do first. So you want to write your equation in standard form. I don't have a middle term, so that's why I put a 0x. And then we're going to solve for axis of symmetry, and then we're going to talk about these other two. So in this case, I know that a equals 1, b equals, they're my coefficient, which is 0. And my axis of symmetry is going to be negative x equals negative b over 2a. So I'm going to say negative 0 over 2 times 1. And then I'm just going to get x equals 0. I'm going to substitute my x back into my equation. So you're going to say y equals 0 squared plus 17 over 2. Y equals 17 over 2. So remember, our x was 0 and the y equals 17 over 2. So now I get a point 0 comma 17 over 2. So let's go ahead and put this all together. Axis of symmetry is x equals. So this right here is going to be my AOS. So axis of symmetry is x equals 0. My vertex is going to be 0, 17 over 2. And I need to know if this is a maximum or minimum. So the leading term of my parabola is going to be a positive number. In this case, it was a positive 1. So that means it's going to open upward. My vertex will be here. So that means that this is a minimum. Okay, example D. Parabola y equals negative x squared minus 6x minus 1. Find the following. Axis of symmetry, vertex, and minimum. So we want to identify the A, B, and C. A equals negative 1, B equals negative 6. So I'm just going to start the work over here. I think that's all I need. So x equals negative b over 2a. I know that that's going to be negative 6 over 2 times negative 1. That's going to mean that x equals negative 3. So I'm going to substitute this x into this equation. So negative 3 squared minus 6 times negative 3 minus 1. I get negative 9 plus 18 minus 1. So then I get 10. So remember, it was y equals negative x squared minus 6x minus 1. So y equals 10. And then I'm going to get negative 3 comma 10 when I put my x and my y together. All right, so axis of symmetry is just the x. X equals negative 3. My vertex is negative 3, 10. And now let's talk about the max and the minimum. Which one is it? Because the leading term is a negative 1, I know that my parabola is going to be upside down with a maximum. So this vertex is a max. Example E, a parabola equals 4x squared. Find the following. So let's talk about the A, B, and the C. Y equals 4x squared. And this is going to be plus 0x plus 0 because it doesn't have the rest of the form or the equation in standard form. So A equals 4, B equals 0. And I'm going to say that x equals negative b over 2a. So I get equals 0, 2 times 4, x equals 0. So we're going to substitute the 2 into that. So I'm going to get 4 times 0 squared plus nothing else. So it's just plus 0 because all of these are zeros. So I get y equals 0. If I put this all together, I get 0 comma 0. So my axis of symmetry is going to be my x equals. So x equals 0. My vertex is going to be the x and the y together, which is 0, 0. And I want to know if this is my maximum or my minimum. The leading coefficient is positive, so that means my graph is going to open upwards, so this is a minimum. Okay, let's go ahead and do F. Parabola y equals negative x squared minus 3x. Find the following. Acts as a symmetry, vertex and maximum and minimum. Okay, so this is in standard form, but it doesn't have the constant at the end. So I'm going to say that my a equals negative 1, my b equals negative 3, my acts as a symmetry is x equals negative b over 2a. You just need to memorize this formula. So that's going to be negative 3 over 2 times negative 1, and then that's going to be 3 over negative 2. So that's what my x equals. Then you need to substitute this x into the parabola so you can get a y. So y equals negative 3 over 2 squared minus 3 times 3 over 2. All right, these are fractions. So you want to make sure that everything has a denominator. Order of operations is what you're going to do first. And when we're doing order of operations, you need to distribute the squared into here. And remember, negative times a negative is going to be a positive. So I'm going to get negative 3 squared is 9, and 2 squared is 4. And then when I multiply these fractions, I multiply going across. So, oh, that was a negative, sorry. So a negative times a negative is going to give me a positive. 3 times 3 is going to be 9. 1 times 2 is going to be 2. So I simplify negative 9 over 4 plus 9 over 2. You need to have the same denominator to combine fractions. So you're going to make this a common denominator between 2 and 4, which is going to be 4. You're going to multiply the numerator and denominator by 2. So I'm going to get negative 9 over 4 plus 18 over 4 equals 9 over 4. And that's going to be my y. Y equals 9 over 4. Okay, so the axis of symmetry is going to be the x alone. X equals negative 3 over 2. The vertex is going to be the x and the y. And I'm going to put them together. So that's going to be negative 3 over 2, comma, 9 over 4. I need to know if that's a max or a min. My leading term is negative, so when I graph this, it's going to be a max because my vertex is going to be at the top.